All right. Last week, Rachel.
Already? It's gone so fast.
Yeah, three parts. The return of the query.
Well, we started with A New Hope, right? And then it was the
return of the query.
No, it was
return of the data model. No,
data model strikes back.
Oh yeah, data model strikes back, and this is return of the query. Yeah. Okay, so obviously there was a Star Wars montage there,
which we didn't follow through in the slides at all.
No, but I think, believe me, there's going to be plenty of Star Wars this year with a new movie coming.
Oh yeah.
It's going to be outrageous.
And if you go to Summit, I'm sure there'll be Star Wars themed stuff.
Plenty of that, right? Exactly. So we are live in Austin, Texas today, and it is approximately 105 degrees Fahrenheit outside. So we're going to stay inside and do a webinar.
Yay!
So where were we last? Or we can't say we because this is obviously going to be watched asynchronously later on. So part 1 and part 2 in the bag.
That's right. Yeah, part 2. We had a very nice conversation of why is Cassandra and an always-on distributed system even important, and how did that happen? And pretty much it happened because of Steve Jobs. We decided on, right?
Yeah, he created this problem. He put that thing in our pocket that takes more attention than anything.
What? I can hear you. I'm looking at my iPhone.
Yeah, I know. So the part 2 is really more of an in-depth look at what Cassandra data model is about. It's not application design though. So we're talking about Cassandra query language, CQL, more details about that will translate into what we're going to do today. And today we're going to talk about actually building an application. So bridging on those first two topics, we have this is how it works, and then this is the details of how to make a data model work and why. Now let's talk about really building an application.
And so if you haven't watched the last two, probably the part 2 is the most important here. We are not going to be going through CQL at all. We're going to assume you understand what we talk about when we talk about a partition key and a clustering column specifically. And we are also not going to go into how data is distributed or why. Again, that's in part 1. So yeah. This is a fair warning.
So let's start this by setting the Wayback Machine. Let's go back. I'm going to data model like it's 1999.
But weren't you more concerned about the Y2K bug at that point?
At that point, I had given up on COBOL, so no, I wasn't really concerned about it. But yeah, so this is, I think I was doing this all the time, data modeling, Oracle, web applications. That's when it really got serious for me. And it was always the same thing, right? And that's, you can go way back. So this is a quick sketch of me and Rachel in one of our early whiteboard sessions in the cave. And so if you'll notice, I mean, this is a funny picture, but what do you see there? This is an ERD, right? A one-to-many relationships. And so data modeling was a exercise you started first by looking at your data. So this is the process. And I think you'll probably remember this. It's like you take this data domain. Hey, we have a problem in our data. Here's the scope of all the things that we need to talk or to deal with, store, query on. Let's go through a couple of design sessions and work up our data model.
Sounds good.
Yeah, and that was all about normal data, not
in traditional OLTP systems. I mean, it was a big deal if you were going to do something different, like if you're going to denormalize your data and do star snowflake schemas.
Right. And in the case of building a web application, denormalizing was not okay. No. Normalizing was what we did.
Exactly.
And you tried to walk it up to how many normal forms you had, and why? Because the application, you didn't know what we were going to do. So you were going to just build out the models, and then everybody went to see one of these, right? Here's your application. You don't know what's happening, right?
But why? So what was why did people normalize data? What was like the driving theory between why what made normalization the right thing to do?
Well, if you take it way back, you get Peabody and Sherman to set the Wayback Machine to the 70s, record format was what was before relational format. And it was just everything was in a huge record on a mainframe or multiple files, but that was because you had a limited space. And with relational, it was about creating the relationships between data that then you could form together using a query. And the normal forms gave you the most flexibility for those queries.
With reducing the amount of space you were using.
Right, and so you would reduce the amount of data duplication, and you're saving every little byte. And that was great back when I had a 20 meg hard disk, right?
Yeah, I think I have gosh, I don't even think anything comes in 20 megs.
No, I can't even get an SD card like that. So we're going to have an example today. I got a little ahead on the slides, but this is a real application, and we're going to introduce it to you right now. If those of you have seen other presentations at DataStax about Cassandra and web application, you might be familiar with this. This is Killer Video. It is kind of like a YouTube competitor.
No, it's not. It's a sample application.
It's a sample application. It is 100% real. And at the end of the presentation, we'll give you all the details of how you too can have your very own killer video. But we're going to walk through this.
But it's a real sample application. It's
a real sample application, yes. It's not a competitor to YouTube, but given the amount of effort they put into it, it could be. Yeah.
You did a wonderful job with it.
Yeah. So here, this should either strike fear or happiness in your heart if you have done this before. And I say fear because this is where you get pretty crazy.
Yeah, I preferred Irwin.
So. Irwin, yeah, okay. Well, this is actually a Oracle data modeling product, and I for these slides, and for this presentation, I fully immersed myself back into the Oracle world.
You did what?
That's right. I have Oracle 12 running on my laptop. I'm using all of the Oracle data modeling products, and yes.
Well, I remember installing Oracle was a real nightmare. I assume it's gotten better, right?
It was not. Yeah, it took me 2 days to get that installed, and so anyway.
So no.
No, not at all. So this is an entity relationship diagram of Killer Video. Now, you can see the relationships. For instance, if you look at the upper right, you see users have many video events or have many comments. And you can see the relationships are marked by, there's constraints, and you can map out everything here. This is a pretty good diagram. And from this, as an application developer, I can look at this diagram and say, hey, I know what queries I need to do. Like if I need to say, well, I would like to know for a user all the video events for a particular video. You know, that's a query you could ask of this, right? Or
right. Well, let's take a step back. You said that this was the data model for Killer Video. It's not the data model for Killer Video because Killer Video is written on Cassandra.
Right, but if I was going to take it from a relational standpoint,
right.
And actually we went through a design session on this, and I'll post the schema for the SQL for this, but yeah, we went through a design session like this is how we would do, but this is before doing anything. We don't even know what the application is really going to do other than we know what all the domain and the data is. So we're building the model first.
Okay.
So if we drill into the user side of things, you can see that I have some, my data is nicely normalized. There's no duplication of data, which is good. That's what's following normal form. And so when I go to take this,
the key, the whole key, and nothing but the key?
That's right. You can then get the physical data model, which is whenever you create a table. And this is the user table. So I create the entity table, and it has some parts in here that we need, like constraints. I'm going to say that email is going to be unique.
You would hope so.
Right.
It's probably as good as anything.
Right. But I have to I'm telling part of my data model, I'm saying, hey, I want this to be unique, and then your favorite index.
Yeah, but so why are you putting this index there? What made that decision?
Well, if I'm getting potentially if I'm going to query on the users table and I want to look up by email, you could not have an index on it, but what would that create?
Oh, one of those lovely table scans.
Full table scan, yeah. So by indexing, what I'm really saying is I'm presupposing that I will use email in a query, in an equal query, a greater, well, probably not a greater there, maybe a like. This is just saying I'm going to query on email. And then foreign key constraints, which gives me this linkage between users and a video. If you notice that there's a user ID in the video table, so that users have many videos, right? That is clear in this model because that's the foreign key constraints at the bottom down here where it says foreign key user ID.
Like caveman has many animals.
Right. back in the old cave. Exactly. Yeah. So this is. I don't think there's anything wrong with this data model, although someone might tell me.
No, I'm sure. Yeah, and yeah. Let's just say that this is for illustrative purposes.
Right. It's a legitimate data model. So what's next then? Not now.
Looks like there's a fork in the road.
Yeah, we do have a fork in the road, and it's funny because we found a picture of a fork in the road, but really this is what we're going to do now with Cassandra. It's different, right?
Totally different.
Yeah.
Like.
And that's why you're here. You want to know the difference. And so I gave you like here's your old familiar pastures, so to speak. And now let's see what we have a fork in the road. We're no longer going to do that. We're going to go a different direction. First thing you have to know.
You have to have your application. It's all about everything starts with the application because if you. And this actually stems from some of the practices of denormalization in general. So when I used a data model back in the days of data warehousing and do my star schemas and all that, I would spend a lot of time, and I worked for Vail Resorts doing this, so I got to spend time on ski lifts actually having these meetings, but asking people what they wanted. What did my marketing team, what questions did my marketing team have answered? Like, so I would say, all right, tell me what you need. And then I would go say, all right, and then I would go interview all the systems people and say, okay, what data do you have? And then I would build these big ETL tools that would take the data from my source systems and put them into my star schema, which would hopefully answer the questions that my marketing people had. And
that was because data warehousing, you don't know. It's just, hey, here's a collection of data. I don't know, and I can use some really epic SQL to figure out, do some really interesting queries and subqueries and joins and outer joins.
You had time.
You did have time, yeah. So Cassandra is completely on its head on this. You need to know more about your application before you do this. Now, go back to video number 1. I believe I said this, or you said this.
Somebody said it.
Somebody said it. Cassandra is a database for applications. This is what we're trying to accomplish is we have applications that need uptime, we need scaling, and users just won't deal with any other choice. They're not okay with downtime. So we're building...
And slows down, too.
Slow it down, too. And we're building an application using this database. So we have to think about the application first.
Right.
Then we build our models. And I think that's that's really interesting and probably where I get the most questions is, how do I build these models when I'm really not even sure what I need?
And what do these models look like? Are they like our traditional models, or are they different? And what's the deal?
Let's deal with that. So again, thinking before you model. So we're going to walk through that process. And we're going to take it top down here. So we do not have a database without any relationships. Now, it's not a relational database, but our data has relations.
Well, I mean, there's going to be relationships inherent in every bit of data, especially when it's application driven, right?
Right. And we're not going to deny that. That is going to be the case. So we already know that users have many videos, and what we've added. This is actually taken from our formal data modeling class, DS220, which is available
now on Data Science Academy.
Right. And so there is a formal data modeling process if you want to take your game up a little bit. But I'm going to walk you through just the highlights here, just so you give you an idea.
Okay.
So
let's see. I see lots of M's and N's and stuff.
Right, and that just acknowledges the fact that there is one-to-many, many-to-many relationships, but what the relationships are, and then some of the properties of those.
And how would you come up with this? Is this based on, like, where did this data domain come from?
This is when we start talking about our application.
Okay.
So when we'd say we're going to build killer video, here are things that need to be there. This is a standard application design discussion.
Okay.
Whiteboard, hey, we're going to have this thing that's going to tape over YouTube. Well, what are we going to need?
So who would be involved? Who would the people be involved in this conversation?
In this case, probably developers and architects.
Okay.
Maybe product people. Make sure that the product domain people are involved. This is the people involved here because we want to make sure that we got all the parts. We're valid. Yes. Okay. We do need to have a user with a first name and last name. Check. So this is really not, we're not getting into the physical data model yet. This actually could live outside of Cassandra as well, which is interesting. But we'll quickly change that. So let's model our queries. So we have to ask these questions. What is our application workflow? Do you know?
for killer video?
Yeah.
Yeah.
I think we can do that.
It almost seems like it's better to do this after your application is built, or
no.
No?
No, and I'll show you. Well, it will be part of the design process.
Okay, so you might be doing this later than you would in a traditional.
Right.
Okay, so you might actually start the data stuff, the database stuff.
Earlier.
Yeah.
Much earlier, yes. Because you're building your application, you're saying, well, how am I going to access that data based on the application workflow? And then I need to know these, like this is, there's a capital there. Not. Yeah. This isn't something that you can just gloss over. You can fake around bad data models with good SQL or bad SQL, as it may be. But you really don't get that choice with Cassandra. So that's why we're walking through the process. And you know, this is I think this bullet makes you don't get joins, do you?
I think I was talking about that in the first couple of episodes.
Right. So here's a sample. This is in that design session, we talk about not just the people, the entities, but this is really thinking about our application. It's a top-down workflow. And that workflow is like if you take it to the left here where user logs into site, here are things that they will probably want. We want to show them. Show basic information about a user. Hey.
Hi, user. Welcome back.
Exactly. Personalization.
Yeah.
How about the videos that were added for that one user?
These are the last 5 videos that you uploaded.
Exactly. And, you know, that show the comments, well, yeah.
And this is what you thought of those last 5 videos.
Exactly. So these are, I mean, yeah, I think we can, and this is still product and development people and architects talking about this. And
same group.
Same group.
Lots of whiteboard.
Notice the subtle difference here. I don't think I really ever did this in relational. Maybe after the fact, and we said, oh, well, we could build an SQL query to do this. But we weren't really thinking about this as much ahead of time.
No, and you had the DBA in the back of the room saying,
no. You're going to need an index on that.
That's going to cost you.
Yeah, I'm going to block that in a minute. So, yeah, we now have a pretty good idea of what we need from our database based on this, I think. So based on all that, look at what we got. We actually have some interesting questions now we can address with tables. And now we're progressing towards the physical data model, which is, you know, actually create table statement. So like when a user logs in, find users by email address. I need that.
Yep, that sounds probably pretty good.
Yeah, and if we look at our videos, now we're starting to see something here. I need to find all videos by a tag, and I need to find the videos by an ID. These aren't indexes, are they?
Well, why not?
Well, let's get into the reasoning. So I'm gonna leave this there for when we put this up on SlideShare, so you can have this whenever you read it. But you've already should have gone through this, and this is, you know, we know our queries, we denormalize, all of these. These are like the data model, how you do things, and this should be from last week, right? And let's look at how we do this with like users. Let's try. Here's a physical data model. So.
And for those who weren't there last week, this looks a lot like SQL because it does look like a lot like SQL. This is actually the syntax you would use to create tables in Cassandra.
Yes, this is Cassandra query language, and it is not SQL.
There's no smoke and mirrors. This is all we'll actually compile and run.
So, and this is our physical data model that is present in Killer Video. And so if you recall with the SQL data model, I had a users table, and then I indexed the email.
Right, because we needed to search by email. We wanted to be able to say, hey, when I have this particular email address, bring me back whatever information about them.
Right, and now what I had to create here, if you look on the left, is a different table.
Right, where we made email the primary key, which in this case means that that's how it gets distributed around the ring. So when we say we want email address equals Rachel@datastacks.com, it will know exactly which node to pull that record from. Right. So that's how it becomes extremely efficient in a distributed system.
Right.
And why you actually need to have that in your query.
This is a critical concept. I don't want to just make this a blanket statement, but most times when you do create index inside of a relational database, you could probably create a table to do the same action. And it gives you the full distributed, like what we learned last week, with the primary key being distributed the way it is and how it can hash properly and get spread out of a much larger ring. You take advantage of that. And you get great uptime, amazing speed with this.
Awesome. But there's email address in this.
Yes, there is. And that is where we are at denormalization, right? So let's first of all, let's talk about the indexes though, because if I'm not creating an email index, right, why not?
Okay, well, I mean, and there are things called secondary indexes in Cassandra. There's
right.
It is available to you to create like the table that we had on the previous slide and put a index on email address. But we know that index is fairly unique. So if you think about it, each node is going to index its own data. So node 80 up there is going to take all the data for, in the case of user ID, that we're in the range of 80, and it will index it. So if you're looking for a specific email address like Rachel@datastacks.com, that coordinator node isn't going to know where that data exists. So it's going to have to ask that node and 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 that node until it finds Rachel@datastacks.com, because it's only going to exist once. And that seems like a whole lot of asking for not a whole lot of return.
And it's going to get worse as your cluster gets bigger.
Right. I mean, yeah, right. Here's only eight nodes, right? Yeah, but that's that's a beginning. That's a starter ring for most people. Now, that being the case, if the thing that you're indexing, or you're looking for gender, for example, gender might have 5 values, 5 unique values associated with it. So therefore, to bring back 20% of the data, when you say, hey, I want everybody who's female, you're bringing back 20% of the data. Okay, then maybe that's a little less inefficient, right? Going to every single node may make more sense. But under the covers, Cassandra is creating tables anyway when you create a secondary index. So if it's doing something in a certain way that's only efficient some of the time, why don't you just take the power into your own hands and create your index tables yourself? Right. And that's sort of the point, right?
Yeah. And, these are secondary indexes have been around since big data.
Right, exactly. That's exactly why they even exist. Because people ask me that all the time. Well, if I shouldn't be using secondary indexes, why do they exist?
I tell people this all the time, and I think this is just really decent guidance, is, take this is your guidance, is secondary indexes are for convenience, not for speed. Okay,
that makes sense. And so not every question is going to fall into the category of being able to do you build your own index. So say if you wanted to do a query where it says where email address like @yahoo.com. So you wanted to pull out all your Yahoo addresses. Right. I mean, you could model that if it was very important, but something that DataStax Enterprise gives you is the ability to put Solr and Lucene indexes on top of Cassandra data. So that would actually be a pretty good use case for when you needed to search all of the things in a table. You might want to look at using Lucene or Solr.
And we see that a lot in production, where using Lucene is from a distributed standpoint, makes a lot more sense than using secondary indexes in that case.
Right, and there's probably a presentation somewhere out there of me talking about this too.
I think there is, actually. This is a long-winded thing of why not indexes, but I think it's important because it's a common pitfall when you come from relational to Cassandra and you see, hey, I can do a create index. It's not the same thing.
It's not, and it makes you feel warm and fuzzy, but it's going to come back and bite you.
Yeah, this is just fair warning, but understanding is important. I think now you know the reason why. It's not just no, now you know why. And and features are coming. 3.0 has some really interesting things that are going to change this story a bit even more. So, I mean, this database is moving in a correct direction. So when I created this table, I hear a lot of people use this as the term materialized view. This is like creating a materialized view of your data. But it is kind of like creating an index of your data. So,
which, let me remind everybody that indexes are not free, and they are not cheap in relational databases. So everybody, I mean, just because you can do it really quickly, it still needs to be managed, it still needs to maintain, and it still takes up a lot of disk space.
Well, it was one of the things, if I had a high insert table in Oracle world, if I had to insert like an inserted table or a table that's being inserted on heavily, I would drop indexes to try to speed up the insert times because, you know, you have to maintain those indexes real time.
And then in my world, when I was a data warehouse, I think 75% of my storage was dedicated to indexes.
Right, and that can take up a lot of space. So yeah, there's no free lunch, it's just understanding the trade-offs. So I have this, you know, this concept that I need to look up videos by user, and I created some order with it as well. So I have this user video table on the right here, and what I want to point out and what we talked on earlier was this whole idea of denormalizing data, where normalizing was about less data duplication, is like one copy of your data for all to use. With denormalizing, we're getting back to this, well, we could have multiple copies of our data. And the trade-off is, okay, there's still storage costs on that, but you're not creating indexes either. But
you are creating an index. You're just having you just have more control over it.
You have more control over it.
At the cost of it's not an easy button any longer.
Mm-hmm.
But I think eventually we're going there, that Cassandra will have sort of easy button indexes.
Right.
Or easier button indexes.
And you can understand why we do this, because whenever I ask for user videos, I don't get a join, so I can't go get the name and the preview image location. But what I'm going to get in a single query on user videos is those two items. I need to return those, because if you think about web and the speed that web requires or mobile, I'm going to do a single query so I can get my data back within milliseconds. I need milliseconds.
Yeah, because
everything is
what I like to say, though, is that you know how long it takes to blink your eyes?
I think it's an eighth of a second or something.
Like 200 milliseconds.
200 milliseconds, right.
But most of my clients that I work with have 20 millisecond SLAs.
Right.
Stuff has to come back in 1/10 of a blink of an eye.
You get 10 of those in one blink, yes, that's great.
Yeah, but that's the speed that you're required to, because as I alluded to earlier, flow is down.
Right.
So if your app isn't responding, and we've all done this, you say, forget this, and you go to a different app.
And I've built these data models before where, you know, the 95th percentile SLA was 10, 20 milliseconds. And keep it up. This is the only way to do this. So when we have some considerations when duplicating data, and here's some of the main points, but the trade-off is, of course, that you need to maintain it, and that is an application problem, that you need to maintain two sets of data, or you have two tables. There are libraries and drivers that help you do that. For instance, SQL Engine, which is now part of the Python driver from DataStax, has some nice features for maintaining two tables at the same time with single data. But this is on the developer. You know, this is where the developer has to be in charge of this particular problem. And again, it's for what you're trying to accomplish with your data and your application.
So you're saying here that the developer needs to take probably a little bit more active role in understanding how Cassandra is actually operating.
Right. And now we've heard that discussions that you don't need to understand Cassandra internals to use it. Well, this is the internal discussion, not the full bore JVM internal, but this is how it works.
Yeah, and it definitely behooves you as a developer to understand this stuff.
Mm-hmm. And look at the successful people that are using Cassandra. They understand this and work with it.
Yeah, and it's not difficult. It's just a different
way to do it. Yeah. Well, I also want to talk about another issue, and that is when we get into, so from last week we learned about how the primary key works, that it hashes the key and it goes to a single node. And so let's look at this data model where we have the latest videos bucketed by day. So that just means that for the partition key is a date format. It's just a string, but it's a year, month, day. And that means that the partition key will be present for a single day.
Right. So that means every row will be for a particular day. All the videos that have been added on that particular day. That's what we're saying here, right?
Yes. And if we're YouTube style, that could get pretty crazy, right?
Right.
Yeah. And what does that mean? Could create a hotspot.
Potentially, right? Okay, so let's give an example of when a whole bunch of videos might be created, all be uploaded on a single day, like opening up the Olympics, for example. Or
the Olympics too, yeah, exactly.
Really?
Yeah, it was. That was weird.
That is weird.
Yeah, because that's when people take pictures and upload those videos. And, yeah. Or a particular cat video is really popular. But
right, yeah, like Grumpy Cat has kittens. I'm sure the tubes full of cats is just going to go crazy.
But we don't know, and that's the problem is that
you never
know when the cat's going to
You never know when a Kardashian is going to crash and burn.
That's right. Those videos are going to be uploaded. And we have to think about this as a scaling problem. So this is where now developers and DBAs can work together. Hey.
Well, wait a second. You just said the developers and DBAs are going to work together?
Dogs and cats living together. Yeah. So, you know, as a DBA, my job was to keep developers from pushing code into production. It really wasn't, I mean. No, you're not going to put your stuff in. But it was more after the fact. There was some consultative thing going on, but.
You're the DBA in the corner saying no. That was me. I was the DBA in the corner saying no.
But since I was also a developer, I had to play both roles. And so this is an important thing. And why? Let's look at how we can avoid the hotspot. And as that data model goes, I'm going to add something in here. So we're going to add this arbitrary thing. This is one way to do it, of a bucket number. And so maybe we can create an integer of 10 things, right? And make it so we can spread that data out. Now,
the bucket number doesn't need to be artificial, I think is the point here, too.
No, I could take a mod of this. Oh, well, I use seconds sometimes.
Yeah, right.
Like there's 10, yeah, I take the tens of seconds.
It's just some sort of bucket, some sort of way of
right.
making your rows narrower.
Yeah. And it seems like
wide rows. We're still not saying don't do wide rows. We're saying
large partitions, yes. I know. You're back in the thrifting. Yeah. But large partitions, and so the bucket number, why bucket number? What is that going to do for us? So I have an example.
Ooh,
so here's our
big cluster.
1,000-node cluster. It's the big one, right? And if I'm just using year, month, day, this is just a drill. It's going to hammer the hell out of that one node. And what will eventually, I mean, for all day, so here's the Kardashians or the kids.
Or today, yeah, today is just that node's going to get hammered today.
Today. All the rest of them are going to sit around and watch as this thing goes up in flames. And, yeah, it's really
That's fantastic.
graphic. Yeah. Thank you, Apple, for making that happen for me. So what happens when we now add the bucket number? Well, this is, I think, you can see now, you get a better plan. It's spreading that out, that load, which is kind of what we wanted in the first place. Partition key, if you use a different partition key, will do that. And if we add bucket number, it will guarantee you have a different partition key every single time. Gives you that good spread on your node locality. You don't run into hotspots, and it's just better.
Okay. Yeah. Well, that makes sense.
And I don't have a flaming thing for this because there's no need. Now, sequences. Right after indexes, the other thing I hear people ask all the time is for sequences. Yeah, this is an Oracle sequence. I created a sequence, increment by 1, start with 1, and then I have a cache of 10. So, and what do I use this for? I could say user sequence dot next val, and I get guaranteed the very next value in order and also non-duplicated.
And let's see how that works when you have more than one node.
It's never going to work.
It's a very hard computer science problem.
Right. This assumes that you will be on, and if you've ever had your sequences get completely log jammed in Oracle world, I feel your pain. I've tried to pull, it's really a mess whenever the sequences get whacked somehow or the cache gets messed up somehow. And it happens. I've had this happen a few times. You have to deal with this problem. So this doesn't work in distributed systems anyway. And so when you ask for a sequence, I know what you're thinking. How do I find a unique number?
Right, because you don't always want to handle uniqueness on your own.
Negative. So we have a user table. Let's go back to the user table. And the user table is UUID as instead of an ID, right?
What the heck is a UUID?
I get that question all the time. This is what we're going to use to identify the unique user. So UUID is a consistent hash, so it's universally unique ID identifier. If you're in Microsoft land, it's GUID. It's a consistent hash, so I can use MD5, for instance, to create. And but every library does it. So it's a 128-bit number, so that means that there is a lot of them. And the guarantee of uniqueness is pretty solid. I'm sure there's a collision at one point in the universe at one point in some time, but who knows. But this UUID is guaranteeing that you're going to have a unique number from the client. So it's the point of view of the client.
Oh, that's interesting, because people always ask me, well, then how do we get our, how do I query you on a UUID?
Right.
Like, I don't just have those things memorized.
You don't. And so in this case, I'm not going to use UUID to like do a search. Then I'm going to use, whenever I create a new user, the client will create the UUID instead of querying the server and saying, can you give me the next value, which in a large-scale system is always going to be either you're locking or you're playing dice. You're just going to spin the wheel.
Yeah.
And with the UUID generated on the client, you just insert much faster that way.
Well, then how do you get it back?
That's why we created the index, if you recall.
Oh.
Yes, on whenever we had the user credentials.
Index table.
Yes.
Not an index.
It was email. Yeah, well, we created an index table, thank you. Where we had the email address as the primary key. And then one of the columns was the user ID. So we could do a search on email.
Which is a much more reasonable.
It means you insert into two tables when you create a new user, but you get a fast lookup for that, and you get a guaranteed unique number, and you don't have to worry about locking, because locking will kill you.
And we talked about that last week about some race condition if you're trying to insert things by email address.
Right. It's not good. Yeah. And using lightweight transactions.
Right. Very expensive locks.
And not needed.
Diamond plated.
Diamond plated, very expensive, and it's like the diamond iPhone. Do you really need one? Topic number 3 of all-time importance for users.
Well, then this was always fun because this is, I think, a very, one of our big clients gave you a, how many page document of fear on this?
It was 20 plus, yeah.
We called it the fear document.
Fear document.
Of consistency. Oh yeah, this is the cap theorem and not so consistent and what do we do? The whole world's going to fall apart. And the thing is Cassandra is commonly known as eventually consistent, but I like to say that it's tunably consistent because you can be as consistent as you want it to be. You just pay for it as far as the amount of time goes. So why are we bringing it up here? It is because it's part of your application design to determine how consistent you need each one of your reads and each one of your writes. You can set a default on the client to always do a certain type of consistency, but keep in mind every query you write, you control how consistent you want that write. So let's go through a little bit about what that means.
Right, and so what I have here is a table of different consistency levels, and let's explain what these are in an example. And this is where, again, developers and most likely DBAs should confer.
Yep.
Because the trade-offs are going to be in both camps.
And probably I would say your developers would be like, I need to be really consistent. And your DBAs will be like, no, you don't. And so there needs to be some type of conversation happening.
I love the concept of the adult supervision of DBAs. Like, I know you think you need this. This is what I love. My conversation is like, okay, you cute little developers. You think you need that, but here's what you really want. And so this is going to enable that conversation.
Right.
So here's an example.
Let's talk a little bit about consistency. So we've got our famous client and our nodes, and we've got replicas, so replication factor of 3. These are concepts that were all discussed in the first part of this series. So if this does not make any sense to you, you might want to go back and look around.
But we're going to glue the two concepts together. Yeah. And this is a very small ring. If you notice that the token range is 0 to 100.
Yeah, it's very small with like IP or something.
Yeah.
All right, so we're going to do a write at consistency level of 1. And what that means is that we only need one of the replicas to acknowledge that it has the right.
It will still write to all 3.
But it has to acknowledge it just has to get acknowledgement from 1. Not from, it doesn't have to get it from all 3. Oh, look, one of them's got it. And it's going back to the client, and we're good. Score! We have a good write.
And that's all it really, and that's what, from the client point of view, I just needed 1. It doesn't mean I'm going to say only write it to 1. I'm just saying I need an acknowledgement from 1.
Yeah, act back from 1 of the nodes.
So think about the type of data would be like, I don't know, usually like the common concept is like log data. Like I'm writing log data, I just want to make sure it's in there. I don't really need consistency to very high because I'm just throwing it into the database as fast as possible. And consistency in this case is not my concern, it's just that it is written to the database.
You just need to make sure that it eventually gets there.
Right. Surprisingly, and there's a great talk on this, by the way, Christos Calazantis from Netflix.
Oh, yeah.
Look him up. Awesome talk about this.
Yeah, eventual consistency does not equal hopeful consistency.
Right.
It's a really good worth 15 minutes of your time. I think that's all it is.
It's very good.
Yeah, Netflix did some really good studies on all this.
So now, why this trade-off? Why do we need this in this situation? So I'm back to writing 1 again. Uh-oh.
2 of my nodes are down, maybe because I put hotspots in there, and they're up in flames.
Or some idiot unplugged them in the rack.
Again, the toddlers and chickens running around your data center.
So we have this problem we have to avoid, and so this is where the uptime issue gets addressed. And with consistency level of 1, the trade-off is I'm going to be fast. I only require 1. So I'm going
to be always available.
Always. I mean, there's 1 replica available, you're going to write to it, and it'll acknowledge it, and your client is keenly unaware. And that is exactly what your users are hoping for.
But behind the scenes, Cassandra has mechanisms in place to make sure that those nodes that have the X's on them right now eventually get this data.
Right. So this is beyond this conversation, but there's a concept of hints. It's called hints, and that's where the node
repairs and full repairs.
All goes back to the Dynamo paper, but this is managed in the background for you as a service, and as
a service.
And as this stuff is getting written to one server, you know that it will get eventually put onto the other server, and that's where the eventual consistency comes from.
Right.
These nodes are not online.
No, but eventually they will get the data, but believe us, and maybe we'll do a talk on this in the future, when we say that there are many, many different release valves along the way that the data gets there. It's not just once, it's not just twice, there's 3 or 4 times that, and the last time is a completely anti-entropy thing where all the data is going to be completely in lockstep at the end. So that is what we mean by eventual consistency.
Right. So new trade-off. So now we've upped the level of consistency to quorum. And
quorum, which is I like, people say 51%. I like using the formula, which is replication factor divided by 2 plus 1. Rounded down.
You're the math major.
Yes. I like the formula.
I like 51% because I'm an engineer. But what does that mean? The trade-off.
Right.
I know you want to argue with me, but don't. The trade-off here is that if I have 51%, I'm getting really good, strong consistency because that means that 51% of 3 replicas means at least 2, or your formula.
Yeah.
At least 2, still the same answer. At least 2 of those replicas have to say, I got this. So when I go to write that data out and I say, I want a quorum, and one of them dies.
We're still cool.
Still absolutely cool because we have 2 nodes that can respond back and say, got this, and your client, again, keenly unaware, but you're getting a good, strong consistency in your data.
And if you read and write everything at quorum, you're basically reading and writing everything as mostly consistent.
Mostly consistent. And this is a really worthwhile thing to mention, too, if we're talking about writes in this case. This is for reads and writes, and they're completely independent per call in the client.
And the clients have the ability to downgrade your consistency settings. So if you start at quorum and it can't fulfill quorum because the world has ended, it will retry again at 1.
Right.
You can set that. Yeah. That's completely in your control.
Absolutely. So this is one of those fundamentals, is understanding the relationship.
It's not to be scared of either.
No, it's not anything to be scared of, but this is a very fundamental thing. It's understanding the relationship between your replication factor and your consistency level. Again, developers and DBAs working together on that. Yeah.
Don't cross the streams.
Don't cross the stream. You know what happens? Stay puff marshmallow. The drivers now. We're going to shift gears into actually writing code. But
I did just mention the driver. Like, drivers have these options here.
Drivers have an option. Very good.
I set up a.
Well done. All right.
Set up a transition there.
That was a very good transition. So when we go to write our application, the driver is a critical part of this. Obviously, this is how we, our API, how we get a hold of Cassandra with our application. So what you have to choose from, and just a quick tour here of drivers. It's DataStax. We've devoted ourselves to trying to create a very comprehensive and consistent package of drivers.
Eventually consistent.
Not eventually, no, 100% consistent. Where we take some of the more popular languages, and these change all the time, right? But I'm sure Rust will show us face here pretty soon. But Java, C#, Python, Node.js, Ruby, C++, PHP are all supported drivers from DataStax. And in the community, we have drivers in Foreclosure, Go, Erlang, and there are others that I see popping up from time to time. But these drivers, what are they going to do for you? And then when I say they're consistent, like the experience is consistent, by what? Here's an example of this is a slice of Java code.
It does definitely looks like code.
It is code. But what I want to point out here is whenever we create the cluster, the conceptual part of this from a programmer standpoint, it should be, I want to connect to a cluster. So yep. I connect to just a contact point. Now in this case it's localhost because I'm doing it on my laptop. But I don't want to have to think about managing the cluster inside my code. If servers are coming and going and all that stuff is happening in the background.
The servers come and go.
So they do. And you should not have to rewrite your application code, A, or B, deploy a new configuration file. And man, that was one of the hard things to manage in production environments is configuration files and making sure they're all correct. What I built into my code here, now this is part of the consistent driver experience, is that we have a way to connect to the cluster, so by adding some seeds or by DNS name, and then we can specify retry policies, like what happens when bad things happen, right? How do we manage that? And then load balancing. How do we make sure that the data is being spread out among all the replicas very nicely? Like for instance, in this case, I create this token aware policy. So I'm actually looking at the partition key and not going to a coordinator. I'm going directly to where the replica is. And I'm keeping it in the same data center. So I'm not crossing data center lines. Yeah.
Nice.
It's very fast. So I'm showing you this in Java. Guess what? Same experience in something like Python. So if
That's nice.
It is very nice.
You get the same stuff.
Mm-hmm. I mean, the two languages I use the most are Java and Python. But if I use the Cassandra driver, I don't have to rethink about how I connect and do things to the cluster. It's a different syntax, but I still get these three things. And that's the consistency. And you should understand how those work. That's about all I'm going to get into that with. I mean, we have plenty of talks about writing application code, but I want you to understand.
Language-specific talks.
Right, language-specific talks, tons of information on this, but I just want to keep this on point of when you're doing this, this is where, again, you can even work with your DBAs to make sure that the contact points and load balancing policies are correct for what you're deploying. So to finish up here.
Yeah, well, I mean, so if you are listening to this talk, the chances are that you have some experience with Oracle, and probably Oracle has paid for your car.
My house.
And your house. And having those skills in various places is your livelihood. And there is some fear that happens when you say, okay, if I develop a new technology, am I going to, what's going to happen? Like, what's going to happen to my job? Like, am I going to Am I going to lose my job because we're going to bring in this Cassandra thing or this NoSQL thing, and all my years of Oracle experience go poof?
Not at all. And I think, if anything, I'm living proof of that. But we have, here's some roles that I could easily define just, by looking at the separated roles from when you're an Oracle developer, Oracle DBA. These are the things we're separated. But what I want to show you now is that things are changing, right?
That fork in the road.
Yeah, we now have a bit of a Venn diagram overlap where the DBAs and developers do need to work together, but they do have their own separated roles.
Yep, but there's definitely more overlap here.
The driver setup, like I just mentioned, like picking the right consistency levels and things like that. Capacity planning used to be all DBA.
Yeah.
Developers can have a hand in that because they're going to be able to create tables to help capacity or hurt it, right? So they have to be a part of that capacity planning. So it sure looks bright.
Yeah, it does. Well, and let's see why. We were Patrick and I were on a plane yesterday, and we were using in-flight Wi-Fi, cruising at 30,000 feet, and we said, well, how bright is the future? Like, what is the job, let's get down to brass tacks. What does the job situation look like for people who are using Cassandra?
Looks really good.
It doesn't look bad at all, does it?
This is a percent of growth in jobs on Indeed.com, taken, as Rachel said, as of yesterday at 30,000 feet. And why are we showing you this? Well, if you're listening to this webinar, you are probably a professional in the field. And I've had this question brought to me several times, not as much lately, but in the past, is am I risking my career or making a potentially career-ending choice by choosing to go with something like Cassandra to work with? And I think this evidence shows pretty clearly, no. There's a high demand for qualified Cassandra people out there, developers, DBAs.
And you know what? We actually are giving you the chance to become certified too. So you can be that person on your team.
Oops. Oh. First of all,
yeah.
Here, we'll put this online before we get to, we're going to make you smarter. If you want to actually do this, this is all living online. Go to killervideo.com. Luke Tillman, the guy who wrote the C# version of this, and it's coming with different versions soon. This is all on GitHub, and just go nuts. It is really, the application is really cool. All the scheme is there. You get a top-down. There's even some great demonstrations of how it works. If you're an application developer, this is one to look at for sure, because if you're like me, you like examples.
All right.
All right.
Skip ahead.
No, that's all right. I didn't warn you that I had 40 slides and not 39. Now you can give people
I know
some
what
money.
you talk about it. No, well, I do want to say that this is, we are doing our first certification. We're partnering with O'Reilly at the Cassandra Summit this year. So you can get certified and become the badass in your company that is the first person to do Cassandra, to be certified, to bring this type of technology to
an O'Reilly certification. That's legit.
That's totally legit.
That's legit, yeah. And think about this as your next big career move, as is really going to enhance your career. I get recruiter emails all the time. I need Cassandra people. Think about this in that term, because it will make a difference. And so these 3 webinars we had give you enough information to learn more. They should get you somewhat dangerous, but go to DataStax Academy, academy.datastacks.com. Learn as much as you can. Plenty of courses, plenty of stuff, all free. Learn. Show up at the summit. Get your certification.
And we're training people before the certification test,
Training day, yep. And you got 25% off.
So if you're like me and won't actually watch online videos and require somebody to stare in your face and say, learn this.
Well, it's comprehensive, yes. So I think we're at the end here. So
yeah,
we are. We got 5 minutes. Devin, in the sky, do we have questions, sir?
It is I. Yes, we do have questions. First question. If servers or Cassandra nodes come back after a long period, like 6 to 8 hours, how does the replica work?
6 to 8 or 68?
6 to 8.
It could be 68 too.
It could, yeah. I mean, I've had servers down for 68 hours.
Okay. You want to take this or shall I? All right. So the hints that we talked about, and again, this is a huge topic, but I will try to nutshell it as best as possible. When a node is down, other nodes will store the changes for it, and those are called hints. And the hints are stored locally on those nodes until that node comes back online. Now, there's a configuration value that allows you to choose how long those nodes will store. Like, it won't do like a FIFO buffer, but it just won't collect hints anymore. And the default is 3 hours. And
you can change that based on how long you know your outages last, how long it takes you to replace hardware, or how much disk space you're going to have on the things. Because I mean, if you collect hints forever, it's
going to cost you. It's going to be a lot.
It's going to fill up. Yeah, it's going to fill up your database. So.
Yeah. Outside of that 3 hour window, then when the node comes back online, it will replay those 3 hours that it missed, and then anything left will have you just do a repair on it. You run repair. If it's beyond what the default we have is 10 days, this is GC Grace. This is how long tombstones exist inside your system. If it's beyond that, you want to kill that node with fire.
Yeah. Well,
take it
out. Fire. Just take it out of the ring. Well, take it out gently.
Yeah, take it out gently. You want to do a remove node and rebootstrap it back in. Because
eventually when it comes back in line.
Yeah, you